Hello everyone, in today's video we're going to be taking a look at input and output inside of Archean with the Xenon code programming language. Now at this point you should be familiar with the concept of scope, you should be pretty familiar with the concept of variables, you should be okay with some kind of the ins and outs, like the basic stuff, because we're going to get a little more complicated. And once we bring in things like iteration, oh boy, it's going to get interesting. So what we're going to do today is we're going to make a program that controls this lovely wheel. There's a lot of things we could do with this wheel, obviously. One thing we could do is we could make it turn. Other things we could make it break. As a matter of fact, if I press the V key on it, you'll see that there's a lot of different values that this particular wheel has. We could turn it. It's got gear. Oh my goodness. There's quite a bit of extra work on here that we need to be kind of mindful of when we're going to be considering what we're going to be doing with this. As a matter of fact, for those of you who happen to have the wiki handy, which I always kind of keep open in the corner, you'll notice there's a lot of inputs and outputs we have at our disposal here. Now, we're going to have to figure that out in order to figure out how to code this thing. Let's do it. So the first thing I want to do here is I'm going to come over to this wheel. I'm going to look at the wheel. I'm going to press V. And where it says device alias, I'm going to give it a name. And the reason I'm going to give it a name is because once you start getting complicated, as I probably showed you in the first video, you're going to want to be able to quickly and easily know where things are so you don't have to change them 1,000 times. So I'm going to call this one wheel left. Actually, we'll be even better. We'll do wheel front left. Now, if I want to be even better than that, we could do wheel FL. There we go. Now I'm actually going to get rid of that mud guard. I'm going to hit myself in the face with it if I do that. All right, wheel FL. Now, what I've done already, as you can see, is I've run an electrical cable to it, and I've also run a data cable to it. It doesn't matter what hole I put the data cable in. That's not going to affect anything for what we're going to be doing today. So let's go ahead and head down to my code. We'll go File. We'll do New Program. We'll call it Wheelio, because why not? And we're ready to go. Cool. So what do we want to do here? We want to be able to get the inputs as well as send values in the form of outputs. Now, if you remember a moment ago, there's quite a list of inputs and outputs that our wheels can have. We have accelerate, we have steering, we have regeneration, which is a fancy word for basically regenerative braking. We can basically brake the tire by just making it into a motor. Very useful, by the way. We can brake. Notice, by the way, we have values that are either Boolean, 1 or 0, and we have values that are continuous, 0 through 1, and we even have a gearbox. Now, the interesting thing about the gearbox here is there's actually 3 values. It's not a continuous. At some point, they'll make this continuous. And of course, we have a couple outputs. We have a rotation speed, and we also have how much friction we have, which is actually kind of an interesting thing, given that we'll have no friction because we're in the air, but you can't win them all, so to speak. All right, let's get set up here. So what I want to do is I want to be able to control my values separately from each other. Now, this is where programming design and architecture start to slink in a little bit here. We need to think about what we're going to need, and we're going to want to assign those to values. So if I change one value, I can change 100 tires worth of values at the same time. So let's go ahead and figure out what we need here. Let's go pull that down one more time. Oh, now I can't see it. All right, so I'm going to create a var for accelerates, and I'm going to set that to a number. Again, I'm going to make this a global scope just to make it a little bit easier. We'll do steer will be a number. Regen will be a number, even though it's technically a Boolean, but that's okay. We're going to go ahead and do var. We'll do brake as a number. And we'll do var gear as a number. Run my code. Excellent. Now, why did I do those all as variables? I did those because I know at some point in the future, I'm probably going to have more than one tire. So if I'm not going to do it right now, it's going to bite me later when I have to add 17 tires to this thing, and you'll see what I mean. All right, let's do some magic. So what I'm going to do now is head down here and type in update. If you remember from our second video there, we showed you how update is basically going to be triggering 25 times a second, which is plenty. And what we're going to do is we're going to output a value to this tire. Now, there are several different ways to actually output values over there. We can use the output command if we know what hole it is, or we can call it specifically by its name. I'm a huge fan of doing it by name. I just find that simpler. Some people disagree with me on that. I will show you both ways. So let's go ahead and do the old-fashioned way. So I'm going to type in output, and then I'm going to assign what hole it's in. So I can take a look here, and if actually you push a V here, you can see port 5 is connected to a wheel. That makes it easier for us. So I can do output.5, parenthesis. Now, whatever you put in the parentheses is going to be the thing that you're outputting to it. Now, this is why I don't like this. So if I were to come in here and type in Excel, for example, and press save, nothing will happen because the value of Excel has no value. So let's go set ourselves up an init here, and we'll give Excel a value. Now, what you'll observe is as soon as my code started, this thing started happily chugging away. You can see it is running here very smoothly. You can see we've got a wheel rotation speed of 11. It's sucking power right out of my power. Of course, I've only got a solar panel back here, so it's not going to be very useful for us very long. And it's running smoothly. As a matter of fact, if I were to come up here real quick and set this to a value of 0, you'll notice that everything is slowly spooling down here, and those values are coming down. Now, that's really, really handy if you have something that only takes a single input. When things have more inputs, things get a little more complicated. Let's say we also wanted to steer this wheel. Let's do steer, and we'll do steer 1. Now, if I come in here, and now if you remember from our documentation a few minutes ago, steering will be our next value that we can use for this particular purpose. So I'm just going to confirm that visually here real quickly here. I don't want to make any mistakes because I do it all the time. Steer is 1. Good. Then we'd have to go steer. Now, the value of steer is 0 right now. Actually, it's 1. So if I press save, you will notice it's going to output hole number 5. It's sending a value to the 0 hole of Excel. It's sending a value to the second hole, or number 1 for us for indices. Channel 1 is what they call it, of steer. Cool. So as a matter of fact, if I were to come back here and turn that the other way, you can see that I can snap that thing and I'll flip it the other way. If I set my steer to 0 like that, it would go like that. And the best thing is I could do variable steering. I'll do a little bit of acceleration and it'll do a nice gentle right turn. And you can see that this wheel is taking values through this little line directly into it, and it's working perfectly for us. Now, this gets kind of fun because we could do other goofy things here. If we wanted to be really technical, we could actually come in here and do regen, we could do brake, and we could even do gear in here and actually send all those values at once. Now, when I press save, notice nothing bad happens. That's good. But if we were awful, we could come in here and do something like this. So we could say regen equals 1. That's awful because you're trying to regenerate at the same time as you're trying to go forward. Why would you do that? You can't infinite power this thing. So if I were to come here and say brake equals 0.2, you can see it's hitting the brakes a little. It's actually too much brake. If I do 0.1, it's too much. Again, if I kill the brake completely. And I could even change the gear. I could go to gear -1, and you can see that gives us this really, really big gear ratio. I could do gear 0, and of course I could do gear 1 as well, which is going to give us that 0.5. This thing, as you can see, is buzzing. That wheel is cooking right now. Let's do -1. I think it's like 2-to-1. Oh gosh, what a gear ratio. Yeah, 17-to-1. Can we get a gearbox in this game? Please, Pacholi, please. But you can see here just how quickly and easily it is to actually spit those values out. Now, these values are completely flexible too. So if I were, for example, grab my light bulb, again, this is just a fun little example. I'll go ahead and plug this into the bottom here like that. Go give it some electricity. Of course, I'm killing my battery right now. Let's say we want to make this light ball is plugged into, what is that, hole number 11? Let's say we want to turn it on red. We could theoretically go in here and do output.11. The first one is on, so 1. Red would be 255, green, blue. Boop. And you can see it's red, because again, a value of 1 would be turned on, 255, how much red, how much green, how much blue. If we wanted to make purple, we could come here and make this 255, because again, now we're maximum red and blue. If we wanted to make that lighter, we could do half, but I'll be realistic with you. The RGB is not that aggressive in this game. So if I do like 10 maybe, you got like a pink thing going on here. Maybe if I do like a 127. Kind of, it's purplish, I guess. And again, you can see just how useful that is. Now, sometimes when you're doing these outputs, you don't have the ability to actually directly plug things into your computer. That's when things get interesting. Now, when I build my larger projects, you'll probably observe there's a lot of wiring going on. Not only is there a lot of wiring going on and a lot of buttons and options inside here, but it gets so unmanageable with all the cableage, that's a technical term here, that it's impossible to plug everything into a single computer and still be able to safely operate everything that I'm doing. Now, when that starts to happen, your outputs are going to get a little bit more complicated, but you don't have to panic too much because this game does a really nice job of making it easy for us. So that's where Alias is going to come in. So let's go ahead and take my little setup here. I'll go ahead and shut off my acceleration. I'll shut my steering off too. We'll leave the gear at 0 again, just for example here. Let's say we're in a situation where I can't plug this computer right into this wheel. I have to come up with another one. Actually, while I'm at it, why don't I hit the brakes? Isn't that nice? You could link it to a wheel. We'll do that later on. Let's say we can't plug this wheel right into this computer. You're sitting there going, we're busted. We need another computer. Please don't do that. No, 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 no. It's much, much safer ways to do it. So what I'm going to do is I'm going to output based on an alias. So let me go ahead and close this out. I'm actually going to come over here. I'm going to disconnect this. And I'm going to create something that we're going to use to actually talk to the wheel through an intermediary. Think of it like a router, for example. As a matter of fact, it's called a router. So I'm going to grab myself a router. And again, a router is just a way that we can feed signals to different parts of our craft as they get more complicated. So it doesn't matter what hole I'm going to plug into. I'm going to pop it right in there. It doesn't matter what hole I'm going to plug it into. I'm going to pop it in there like right there. Now, what I want to do is I want to be able to go ahead and send that signal from this computer through the router back into the wheel. Now you're sitting there going, oh, don't we need to know what hole it's in? No. As a matter of fact, let me show you some panic real quickly here. The big router, as you can see, has a lot of connections. So as they increase the number of connections, the panic sets in. No, not really. It's actually still really, really easy to do. Let me show you what I mean. All right, let's open our code. So what I want to do is I want to get this wheel going again. Right now it's sitting there looking pretty darn sad. So I'll come in here and I'll use a new command. I'm going to use output number, left parenthesis, and then I'm going to write the name of that wheel. Now, our wheel, of course, is named wheel FL, quote, wheel FL. Now, this is where things get a little challenging. We have to tell it what hole we want to put the value into. So if I do a comma, 0, I'm saying send whatever value I'm about to do into the 0 hole, which for us, if you remember, is the accelerate one. So I'm just going to do comma, and we'll get our value for Excel. Let's set a value for Excel and hit save. Now, what you'll notice here is I'm sending an output to wheel FL, and I'm sending that value of 1 into channel 0. And what you'll observe is my wheel has not started turning. You're sitting there going, that proves it. You can't do it. No. What it proves is that a router requires electricity in order to route signals. That's an important concept for us. So if I were to grab this wire and I run back here and I'll see if I can find a place to plug it in like that, what you'll observe is the moment the router has electrical power, our wheel is turning, even though it is not directly plugged in anymore. That is so useful. It is unbelievable. And it is generally the preferred method for the purposes of getting values and sending values and things along those lines. I can't say that enough for that particular purpose. And again, we're probably going to kill the battery on this thing. It's just a little tiny battery. What do we got? We got 47 minutes of battery. We're fine. But notice here, if I were to come in here and set this to a value of 0, it stops accelerating. But if I wanted to send a value for break, oh no, we'd have to come in here and do the whole thing again. Break was 0, 1, 2, 3, 3, comma break. Now, if I send a value of 1 to break, you'll see that the break comes on perfectly, just like that. And again, you can see how wonderful that particular tool is for that particular purpose. Now, let's say we want to do some input stuff. I want to go ahead and design a chair so I can actually make this little wheel do things for me, rather than just sort of sit there looking kind of blank. So let's go ahead and do a little bit of a construction here. I'm going to keep it nice and simple. And I'm going to add myself a chair. Let's go ahead and grab myself a chair here. Pilot seat is what they call it. There's actually a really hilarious toilet seat in here. And I'm going to go ahead and connect the inputs here, pop it in here. I don't care what hole it is. I'll go ahead and climb in here. All right. Let's see here. Uh-oh, it's being gentle. There we go. I was just being silly. Now, what we want to do is we want to make it so we can use the controls of this chair to actually do some things for us. Now, one of the things I don't like about the chair is there's a lot of inputs for it. As a matter of fact, if I bring this down here, you'll see we have all of these channels accessible for us. We have auxiliary, we got forward, backward, left, right, up, down, and you're going to go, oh no, this just got complicated. What do? Press F1, press Alt, hit input, and you can see which value is referring to what in the event that you're not sure about this. And again, they keep it pretty simple for that particular purpose. But I'll be honest with you, sometimes I get these backwards, so I always end up opening the sucker up and trying to figure out what on earth I'm doing. So what I want to be able to do is take the output of this chair through this wire into my program, into the input of this wheel. Now, things get a little bit more interesting here. Now, because we were smart in the way we engineer this, it makes it a little bit easier for us to get values in. The first thing we can do is what they call the input command. The input command is, it's interesting. It works, but we've seen the input command before. So let's go ahead and do it with the input command, and then we'll show you how to do it the way that I like to do it. So I'm going to go ahead and type in input dot, and let's see here, what hole are we plugged into? I should really call that a channel. Let's see what channel we plugged into. We're on channel 10. So I could do 10. And then what I'm going to do is, this is going to seem insane, but I'm going to take arg1, we're going to take arg2, we're going to take arg3, arg4, arg5, and you're probably sitting here going, what are you talking about? What do you mean by that? Well, what I'm doing here is I'm taking in each one of these values one arg at a time. Arg1 is simply going to be using. Actually, if I was a better programmer here, I'd call this one arg0. And the nice thing about that is now each one of these can simply refer to a different place. I'm mapping my input. So 1, 2, 3, 4, 5, 6, 7. Gosh, it's going to take a second. Ugh, that is so ugly. You'll also notice I had to declare the arguments as a number. And again, this is one way to do this. So now what we'd have to do is we'd have to do the actual mapping. We'd have to say something like this. Excel equals arg1. The reason we're saying that, if you remember, argument channel 1 is forward backwards, which makes it easy for us. And then we would say something like steer equals arg2. Nice. Aha! When I press the W, it goes, my steering isn't working. Why is my steering not working? The reason my steering is not working is because I never mapped steering. And I have to come down here now and say output number wheel FL 0. Actually, this wouldn't be 0. This would be 1, comma, steer. Save. Look at that. Look at that. So you can see here, I can completely control that wheel from the seat. What I do is I map the input for 10, grab all of the values out of the chair that I want, then immediately load them into this here. So now if I wanted to, I could actually go all the way. I could say brake equals arg3. Of course, I do not remember what that one is. Is that up and down arrow? Is that space or shift? Oh, I never, it has to be spelled correctly. Otherwise, it's not going to work. That would be explain anything. Fullest power, space bar. Oh, look at that. Space bar. Neat. I've got brakes now. That is so awesome. And that is one of the methods you can use for getting inputs. Now, as you can see, this is starting to feel a little complicated. And if this chair were not plugged directly into that computer, this whole process would be quite a bit more complicated for us. We'd have to do some really nasty routing in order to make it work. And in my opinion, there should be very, very little programming actually plugged into your main computer for anything that you're doing. So what we'll do instead is we'll clean this up and do it a little bit differently. So what we'll do this time is we'll simply load each value using the input number command. So if I wanted to do, for example, say Excel equals input number, there's two ways we could do this. We could do it by what output it is, remember 11, or if we were smart, we'd call it something like seat. Now, if I name this thing seat, let's come over here real quickly here. I'll pull that to the side. I'll call this one seat. That means now that I can use this input anywhere I want, and it doesn't have to go into here as long as it goes into a powered router. That means I can do something like this, and this is so useful. Hold on X, by the way. It's a fun trick. And plug it in here. My seat now isn't even connected to the computer directly. It's going through the router, which, by the way, you can router if I need to do like 6,000 of something. The reason that's so stupid useful now is when I get my seat here, I can use that alias to get its values. So what I'm going to do is I'm going to get value 1. I'm going to go ahead and get, let's see here, what are our other values here? I think we had steer, right? Equals input number seat. That would be value 2, helps if you type in seat correctly. Then all we have to do is output number to our wheel. I think it was wheel underscore FL. This would be 0, comma Excel. Output number wheel FL was 1, comma steer. Hey, let's see if it works. Oh, look at that. Haha. And you can see here, my chair is going through a router into the computer, and it's actually driving the wheel directly. Now you're sitting here going, it really feels like you're kind of going out of your way to make things more complicated than they need to. Could you put the brake on, by the way, while you're doing that? Because I'm copying your code. Sorry. Brake equals input number. My apologies. If it's something you need, I'll put it in there too. Let's see here. Brake would be input number 3. Brake, braille. Haha, I love that. Of course, we'll be lazy. Haha, Control V. This would be input 3. And we do brake. Okay. You asked for brake. Here's brake. Spacebar. Love it. So, of course, now that you can see how stupid useful those inputs and outputs are, and you've also seen different ways in which we can do these inputs and outputs in an effective manner. Now, keep in mind, you can theoretically have any number of these, because I can router, and you can even do awful things like use wireless connections to send signals to things. But knowing how to input and output is half the battle. Now, you're sitting here going, Okay, you're going to give us the big reveal why you took so much time to do things which felt like the long way. Yeah, I'm going to do it. Haha, now that's what I call a usable car. Now, let me show you why. So what I've done here is I've linked all of these together. Now watch this. I want to make it so my front wheels steer, my back wheels drive. Okay, how are we going to do that? Well, let me show you. So what I've done here is I've named each one of these wheels just what their position would be in a normal car. So let's get smart. Output number. So I want all of my rear wheels to be the ones driving. So I'm going to do R asterisk, meaning any wheel that uses wheel R asterisk will be all, and again, all wheels, anything, this basically means wild card. Any letter after the R doesn't count. Anything that's wheel R counts. So we're going to send that to my acceleration input. So my acceleration input, of course, as you remember, is input 0, and we're going to send Excel to it. Let's test that. Aha! Notice my rear wheels are the only ones driving. Nice. Now I want to make sure all of my wheels can brake. 0, again, this would be input number 3, and this would be brake. Save. Let's see what happens. Full power, brake. Oh, do you see how useful that is? Now we want only my front wheels to be able to steer. We'll do rear front. Again, we could do the same thing. We'll do 1, steer. Ah, look at this. Look at this. And they all brake. Do you see how insanely useful that is from a programmatic perspective? Because we assigned everything its own value, we can quickly and extend this as fast as I want to, just like that, without anything to really stress about. Now, some of you probably observed the fact that this wheel and this wheel are going to be opposite each other. That's exactly correct. But that's one of the things I wanted to leave you with today. So let's go ahead and fix that. My front left wheel, again, this is my example, save, is going to be this guy down here. My front right wheel theoretically would have to actually rotate the opposite direction. Now, the cool thing is, all I have to do is put a negative sign instead of steer. Watch this. Ha ha, look at that. And my rear wheels still work, and my brakes still work. Isn't that incredible? How quick and how easy it is to configure these things without having to stress. Now, the cool thing is my code is hyper flexible. At any point, I can come in here and tweak these, tweak the way my all-wheel drive works in basically 5 minutes to expand or modify my code. That is why Z9 code is so useful, and that is why it is so important to recognize the value of text-based programming. You can do anything you can imagine with it, and that's one of the reasons why I wanted to share that with you. Next time, what we'll do is we'll kind of play around a little bit, and we'll do our first little, I guess we want to call it case study. Enjoy.